Hey Denver Cyclones, this is Mr. Pickett. Welcome back. I hope you enjoyed our first video, which was all about momentum. What we're going to get into next is we're going to get into, well, this is where we actually left off, is we're going to make sure that we understand the difference between elastic and inelastic collisions. All right, if we remember, elastic collisions are when things strike and they actually bounce apart from each other. And that's easy to recognize. Elasticity means usually that they'll bounce. Inelastic, though, is when things strike and they kind of stay together. And usually they stay together because there's a huge amount of energy that's transferred. If you think about a lot of car collisions, a lot of times when they strike, they don't just bounce off. They actually strike and they deform a couple different things. They cause bumper damage. Your vehicle gets crushed a little bit. So there's a difference between these two types of collisions. And I hope that you checked out the video. It's pretty high end, but I think there's a lot of good things from it. So as we take a look at these two situations, right, do we think that this first one, the orange or kind of brown color, do we think that's elastic or inelastic? And we're assuming that what it's striking is actually like maybe a wall or the ground. So what do you think? All right, so what we recognize is that this first object has velocity, and then it doesn't have any more right now. But what happens is that the momentum is, and I shouldn't say it's not conserved, but what we have here is an inelastic collision. And the reason why it's inelastic is because the objects are actually stuck together, and it's caused a deformation of this object. So what kind of a collision is this second one? It looks like a basketball. You're right, it's elastic. And the reason why it's elastic, even though the ball probably slightly deforms when it strikes the ground, it immediately rebounds, figuratively and metaphorically, and it comes back to its original shape, and it moves off. So we have the orange, which represents an inelastic collision, and then this green, which represents an elastic collision. Okay, so when we think about math thinking, one of the things from the standards that I really want you guys to do is to be able to look at systems or objects and to be able to represent what you see, like your observations, the way that you describe stuff, using numbers. All right, so using numbers to describe things. So here's an example, right? 21 inches. It's quite a long ways. That's the size of a giraffe's tongue. And they literally have the ability to take their tongue and clean their ears with that sucker. Let that sink in. So most of you recognize that a giraffe's tongue is probably really long, but can you actually describe it? What are some other ways that we can describe other objects that we see? So like the packages that I undoubtedly believe that you're receiving right now. Besides the color that you're receiving in probably some sort of a cardboard brown, what are some other ways that you can describe your package? Shopping cart. What if you're going to mathematically describe a shopping cart that's filled with groceries? When it's barreling down an aisle, whether there's a person attached to it or not. So what are some ways for us to describe that? Well, here's some examples. It's definitely not all of them, but here's some ways that we can describe the previous two objects, the packages and the shopping cart. Obviously, these objects have mass, right? Is it big? Is it little? Their dimensions, so their height, their width, their depth, right? And that's usually measured in centimeters or meters, in feet or in inches. And then maybe how fast they're actually moving, right? And in what direction. And so that's another way that we can start to use our eyes to see things, but also to describe them mathematically. And that's a challenge for a lot of kids. They want to observe things based on just what they see, but adding the math in is another layer for you to show your knowledge. So can you describe the momentum of just any objects, right? Do they have momentum? So I think that we did that previously. If we go back to these ducks right here, these ducks were a great example of we're seeing them colliding and hitting and sliding, and those are all qualitative measurements. We're describing what we see, But if we want to quantitatively describe what's happening, we should add numbers into them. And when we're doing that, right, we talked about using an example that maybe this first duck has a momentum of 20 because it's got a mass of 2 kilograms and a velocity of 10 meters per second. And it strikes another duck who initially was at rest, right, but it was also 2 kilograms. And we're adding another layer to describe the motion or just the state of being of objects. So that's a challenge, and I think that's one thing I'd like to see some of you be able to do a better job of, is to describe things mathematically. So here we are. Which ball in here in a Newton's cradle where these things are moving, which one of these spheres here has momentum? I hope most of us chose this one because it's in motion, right? Whether it's moving to the left or it's moving back towards the rest of the balls. And then here's a good question here for you guys to think about. What kind of collision will actually occur? Right? And the reason why we say it's tricky is, make sure you pause and think. Coming back, is that there's actually multiple collisions that are occurring here. So when this ball strikes the rest of, at least this ball right here, there's a collision when these two connect with each other where, for the most part, they stay together. So I would consider that type of collision maybe a collision that is inelastic. And then all of these other objects will actually have their own collisions, and I would consider them to also be inelastic. But by the time we get to the last two objects here, the last two objects are going to have a different type of collision, and it will be an elastic one, where they're actually going to have one that's going to kind of blow out as a result, and it's going to move out the other direction. All right, hey, thanks for watching. I know that there's a lot of stuff that's in here. If you have any questions, don't be afraid to email me. You can find me, maybe not on Facebook, but on Instagram with Coach J Pickett or on Twitter with Coach J Pickett. And remember, this is all voluntary. Stay safe, everybody.